Recording started. So good morning. I'm gonna start sharing my screen. Today is the second class of interface and application programming. Yesterday we saw a lot of processing, P5DS, MAT App Inventor, and today we're gonna be focusing on using the ESP32. That is a really nice microcontroller that you all know, that has like Wi-Fi and Bluetooth, or the smaller version that is the ESP8266. So why we were focusing on this one is going to be because of the Wi-Fi capabilities and the big memory that this microcontroller has. We have been pushing a lot this year to actually try to use this single microcontroller to cover all the resources instead of using Arduino because of the new capabilities that this microcontroller has. So let me move a little bit this slide. Yeah. So what we're gonna do today is how to actually embed an HTML web page inside the ESP memory. So why we will do that? For example, yesterday when we were talking about MAT App Inventor, you remember that for example we were making a simple app, and that app just has two buttons. And if you attended the class, you remember that basically what we were calling was web page addresses, like the IP address in the local network of the ESP connection slash, for example, GPO1, like a secondary address. That address was called by a normal button in an HTML. But we were doing all this with an app, a precompiled app already for Android that was installed as an APK package. So what happened when you don't want to use an app, or you want to use actually everything as an HTML? Because actually this page right now, the Fab Academy class, is an HTML. And when I click MDF students, it's going to call to another address. So actually what we can do is call two addresses, and the address corresponds to actions for the microcontroller. Those actions could be related either to actually modify the web page again, to send you a new web page request. Actually, you are sending HTTP request, and the HTML is sending you HTTP response, and that could be done by changing the color button, or by sending you a new web page, or by showing you an animation, or also can do a local response that will be activate an input or an output. Or actually what you can do is read an input and send all the time HTTP response by refreshing the web page to show you the data of the input. So basically we will we will have a small server inside the ESP that is going to host our content. Before, yesterday in the MAT App Inventor, we only had an Arduino code, simple Arduino code, but that could be replaced by MicroPython or C#, etc. You can do it, C++. You can do it with all the type of coding that you want, but the content was actually outside, was in a standalone application. So, for example, that we have a problem that in case of iOS, it actually doesn't work. Or if you are using a computer or to access your, let's say you want to activate and use the capabilities of the interface of the ESP, you need to have installed the app. So instead of that, what we're going to do is use the ESP to publish pages. So actually everything is inside the ESP, and what you just need to do is connect to the same network, or actually connect to the ESP networks, because we have two different modes of connecting to it, and just call different address and basically have a kind of micro internet of only like 2 or 3 pages for you of what you program inside the ESP microcontroller. So basically what we're gonna do is call addresses. In this case, for example, this is the IP address of the ESP. It's gonna send us a request, and always we need to send back an HTTP response. Sometimes you have read that some pages, when you call them, they say timeout server or etc. or for code Z4. No, sorry, today I'm not having a good day. Code 404. That means like the server didn't respond. It means the server didn't send back any information. So at least we always need to send a code to 200. That we will see what is later. So basically, what we're gonna do, you have different ways of connecting your ESP to your device that you want to control with. You can control with a computer, a tablet. You can even use a Pi. So everything that has a browser could virtually access the application or how you program or the web page of your ESP. We're gonna use as a web server. That means we're gonna use as station mode. Sorry, as a client. So that means that the ESP is going to connect to a local network, and the local network will work as an access point for all the devices that are going to connect to the ESP. We can also work as a station mode. That means that the ESP is not anymore connecting to a Wi-Fi network, but is publishing a Wi-Fi network on its own. That is good, and you will have, let's say, a straight away connection from your device, from your connecting device to your ESP. But this is something that when we publish a web server, we usually don't do. And that's because when you have a web page, for example, let's go site as example. When you want to have, let's say, is now, for example, Bootstrap libraries enable or some JavaScript to make animations, because, for example, this page, all the coming in and out, this is all JavaScripts. Those little pieces of code, those libraries, usually occupy memory. And inside the ESP, actually, we have a file size limit. It's the same as Arduino. Arduino has, for example, only 32 kilobytes of SRAM. So we can only load a maximum of 32 kilobytes of maximum sketch size. Luckily, the ESP32 memory size is around 520 kilobytes as a standalone code. So that means we can have larger files inside. And why we want to have larger files? Because basically we need to code the HTML inside the page. The ESP32, we have different versions. And actually the one that we use is the Broom one. It's, let's say, Model 1, Model 2, Model 3. It happens the same with the ESP8266. The memory size of that one is also for 512 kilobytes. But we have something that is called a SPIF memory. That is actually the total flash memory of the microcontroller. Actually, I have put a link down here. Let's update the page. I don't know why it's not updating properly, so I just will look for it. ESP32, that is called SPIF's memory. So actually, this microcontroller has another type of memory that is a flash memory that is actually sized at 4 megabytes. That's huge for a microcontroller. So all of you have already have done web pages. Actually, you're publishing your Academy and MDF page as HTML, and you always want to keep track of the file size of your page. For example, the Barcelona web page completely weighs 420 megabytes. Of course, we have a lot of class files, codes, images to show the tutorials. But a standard, a small web page could actually look like something like this. That is this page called Zeppelin. This page, for example, this is a web page and it's only 239 kilobytes. And this web page, sorry, it's actually this one. I clicked the wrong one. Is 6.4 megabytes. So actually this is too big already. And this is a standard like control web page. So what we have to do with the ESP is use the secondary memory, that is a space memory. Like you can make the similarity that you have the main SRAM memory of the microcontroller, and you can have a second type of memory that is a flash memory of 4 megabytes. And that's called the space memory. And it's when all the power of the ESP32 gets released. Actually, the ESP8266 has also a space memory, but depends on the version of the ESP that you buy. It has between 1 megabyte, 2 megabyte, 3 megabyte, and the 4 megabyte version. So if you open the Arduino IDE, when you are compiling, you can assignate to actually use that kind of secondary memory or not use that kind of secondary memory. So we're gonna take the most out of this small controller by either or compressing back our web page to lower than 512 kilobytes or using the space memory. And why you want to use the ESP connected through a router? To have whole worldwide internet access. And why that is important? To actually reduce your file size limit of your web page. It means reduce the whole weight of your web page. Why? Because a standard page has sometimes some libraries, some icons. For example, this is the favicon. Usually the favicon is not the biggest problem because favicons are really light. But you have images, you have JavaScripts, you can have animations, or you can have videos. For example, the Academy web page, just the first thing it does is actually call to two JavaScripts. JavaScript of Bootstrap and jQuery, that is for getting Google APIs. And then we go on the back, I don't know if we have more. We have links. No, actually, this page is super simple. But actually, we have here some links. So actually, what we want to do is instead of saving all the files of the web page inside the ESP, we want to call them from other servers. So you are going to load your basic HTML, but maybe, for example, you can host in another computer or a server, for example, a GitHub repo or a GitHub repo, your images. So actually, when you are when you are sending the call, the HTTP request, the HTTP response is going to be a web page that is going to be assembled, is going to be sent back to the device, but the images are not going to come from the ESP. They are going to come from the other server because you are requesting them as a address. And that's good because we can, in that technique, we can make pages really, really light. I don't want to go really further onto this, but it's quite important. Let me show you in Arduino, for example. This is a whole web page with, let me see the chat. I didn't see everybody. Yes, we can have the ESP to write data in another server via app. Actually, we can do this with fibers and etc. Oscar and Xavi will explain this much better, much better than me. So, for example, here, this is to program a ESP, standard ESP. We can choose the frequency, the EOS, and the flash size. Actually, the flash size is what we call the amount of flashes that your device has. Why it states 8 megabytes, 2 megabytes, 16 megabytes? Because on the ESP controller, you can also have external flash memory devices. For example, in this Node MCU that is already built out of the box, ESP controller, USB connection, regulator, and everything, this small guy actually is another chip of extra flash memory. So actually, the inner core of the ESP32 has a maximum file size flash size memory of 4 megabytes. But you can, through SPI, another microcontroller that is going to be basically external memory. Let's say buying another second hard drive. You see the I make with my hands for your ESP controller. So actually, Arduino also knows that it's a common thing, and you can do it in here. And the partition scheme is actually how you're going to store the files inside your standard ESP microcontroller. You can use the default. The default is the minimal, that is a standard 1.3 of total kilobytes of programming, because before I state that the standard flash size of the ESP is 512 kilobytes, no? That is when you use the Arduino, because actually the total standard memory is of 1000, actually is 1.2 megabytes, but you are using 500 something left to the bootloader, and also like having over the programming that is always embedded by default. So you have some parts of the ESP core that you cannot overwrite. So that gives you actually the 512 kilobytes left to your standard code. So if you want to use more, you have to state that you want to use SPIF's memory to actually allow to access the secondary part of the memory, that is that 3 megabytes of SPIF's RAM memory. Is the ESP connected to the computer right now? I don't think so. No, it's not connected to my computer. You see, I don't have a port open right now. Actually, the Arduino doesn't detect which one you have. For example, right now this code is really big, so I'm trying to use minimal speed to compress the app completely. And that's something good, because actually when you upload SPIF HTML inside the SPIF memory, you can upload it as a zip file, as a RAR file. You can not only embed a HTML, but the ESP will decompress your compressed files to actually allow to host more content inside of it. And that's actually something really good, because HTML and CSS can be compressed in a really high rate compared to other types of files. This is just to explain a little bit how to use the web server with the embedded HTML inside the ESP. So in this case, what we're gonna write is basically a web server as access point. It means connected through a router to just control 2 buttons, to control 2 GPIOs of the ESP, to turn on and off. So how we do this? Yesterday, we already saw a little bit the code of the Wi-Fi server and Wi-Fi configuration of libraries of the in Arduino to be able to use them with the MIT App Inventor, because we need to connect first to the internet. So, sorry, something false. So basically, we need to include the Wi-Fi libraries of the ESP, because Wi-Fi is not enabled by default. Happens the same with Bluetooth. You could actually do this with Bluetooth, but it doesn't work as well as. So don't try. It's much better to do it Wi-Fi, simpler. So we need to set up the SSID of our network. That in this case, what it is actually is your Wi-Fi name and the password of your network. We need to initialize the server connection. And what we're gonna do is put a serial begin. To do what? Actually, what we want to do is to have the serial monitor of the Arduino so we can debug things. Actually, I have an ESP here, so I'm gonna connect. And when we do this kind of more complex programming, like stabilizing the Wi-Fi or publishing a web page, you always want to use the serial monitor to actually debug things. For example, here is setting that I have the native portal, etc., etc., etc. So we always want to enable the serial begin to be able to initialize and have a debugging port. We're gonna try to connect, and this piece of code is standard. We never need to touch. It's a standard, just establish the Wi-Fi connection. In all the Wi-Fi examples and tutorials you might find online, is always the same code. Maybe it just states different names on the commenting part to the segment, but that's it. The most important part here is what IP. So on the serial port, your IP address inside your local network. And actually that's quite important because it's what the address we need to set up in the browser. And we have the void loop that is actually called for an HTML. In this case, the HTML is inside the Arduino code. And it's something that you say, what? Yes, because we can host and program an Arduino code, like an INO file, and call to a HTML file. But Arduino IDE and the ESP has some, when you compile for them, you can embed the HTML inside the INO file. So actually you only have one file that has everything, the base code programming and the HTML hosting of the ESP. Why you will want to do that? Actually, to simplify things and only have one file that if it's small enough, you don't need to use the space memory. Why sometimes you don't want to do that? When you have complex web page with animations and a lot of content, getting one single code that might be some complex, quite complex already, and adding all the HTML part will make the file really complex to read and really complex to debug. So in this case, the content of this web page is minimal. We have basically the header, we don't have header. We have an H1 typo, H2, maybe this is just standard text, and a button class, and a call out for an image. So actually, the base code of this HTML is super simple. So actually, we can have it inside the web page. This is something that I just explained to you, that you use the serial monitor to get the IP address. And this is an example of actually how to police a simple server. As you see here, this piece of code, this is just the part of the HTML that is embedded inside the Arduino code. As you see, an HTML could be as simple as just a line of text. We just need to put the tag of open HTML, close HTML, and body, H1. So just with this little line of code, we are not doing anything, of course. But in the moment we call this IP address, the ESP is going to just assemble this code and send it back to our browser so we can visualize. The same as we can just state a line of text, we can state more complex pages. So this is a second example. Sorry. For example, let's try to make this one is using as a station mode. So we have the same, the configuration of the Wi-Fi, establishing the web server, stating up what? Right now we need to we want to activate things. So we need to define the pin conditions. So let pin 1, let pin 2. We want to initialize the serial port and the pins, and we have the Wi-Fi connection. Our void loop will be if we have a client, it means we have a HTTP request. If the HTTP request is let status, write it high. If not, write it low. So if you are requesting a web page that is called let pid1 status, this is going to enable it. It's like calling a second page. That second page is going to actually not change to a page. It's going to answer a request on the digital outputs of the microcontroller. And this is just basically how we actually send everything. For example, when we ask the HTTP request, that is this, we always need to HTTP respond something. So we don't have like code errors in the browser, like the error 404. So if you make a HTTP request, you can just activate a LED. But if you don't want to update the web page or make changes in the web page, at least you need to send a basic line of code. That is the confirmation of that you have sent actually properly your request. So when you enable the LEDs, you need to send back something. And actually, server send 200 text HTML. It means empty answer actually, but you need to answer something. And after that, we have the what is this, guys? Look, is a string send HTML. When you assemble HTMLs inside the Arduino code, you need to state it in a slightly different way. For example, we need to state it like this. We need to state that this is actually a doc tag, so the Arduino can actually separate the main Arduino programming and the HTML programming. And in here, actually, we are not calling two libraries or anything. This is a quite simple one. This is a simple HTML, a standard, clean, without libraries. But let's say, for example, you want to make something like this, way more complex. These pages actually need to have external libraries. And actually, those are links of tutorials on actually how to do it. And I'm going to show you, for example, one example of one project that we have done in the lab that is use the ESP to control a small blimp. Let me show you first what this is so you cannot really understand it. So actually we designed a small PCB, the same as your Arduino, that basically has 3 small motors and is connected to literally a trash bag full of helium. So actually we use the ESP web server HTML inside to actually touch buttons and activate the motors. So you actually can navigate with your small PCB. We try to make actually the web page to control this is super simple. It's just a web page with 3 buttons. What happened? We were sending a lot of requests and we were doing quite fast. And especially the web page, we want to do what? Oop, why has gone out? Actually, you see, we want to add a GIF image inside the HTML request. What happened especially with the GIFs? Any clue? GIFs are really heavy. Exactly. So actually, for example, I'm going to save this GIF. It's almost like 700 kilobytes on its own, just one GIF. So you want to host these kind of things externally. Code Zeppelin, Wi-Fi server. So for example, this is the basic code. Okay, let me go to the chat. Maybe it's me because we are having 2 classes at the same time in this house. If it's going wrong, just tell me and I can try to change from network. Does everybody hear me well, or do I change the network?
It can kind of hear you, but it kind of breaks up here and there, and then there's about a frame per second when you go through videos and pages and stuff. So I mean,
you get frozen a lot.
Yeah, I have a delay as well, but I think because we are using the network super, like we have 3 classes.
Okay, hello?
Yes, we can hear you.
I'm back.
Hey there.
Yes, I can hear you.
I can
Okay,
hear the one word you said.
so you hear me well or no?
Yeah, that's better.
Yeah, it's
Okay.
better.
So actually, for example, this is just the HTML of control of the fab blimp. As you see, this is much better in a way. Why? Because I don't need to have deploy an APK for my Windows operating system and another APK to my Android and another APK if I have a Mac and another APK. Well, they are not called APKs, but applications if I have iPhone, like EOS. EOS? Yeah, it's EOS. So I can just call to the address and it will automatically publish the fably. And it's going to be front to actually activate the motor, left to activate another motor, right to activate another motor, and left to activate another motor. And this is, as you see, is a quite simple app. But I had the problem of what? This image was really huge and I could not enable in the memory and I didn't want to use SPIF memory. Like to use the over 3 megabytes of leftover memory that you have. So let's go a little bit through the code on how this works. As you see, this is calling more files. And actually, you can store also the CSS files. Actually, okay, see, really. Let me change. I don't want to change the naming here. Code Zeppelin, Wi-Fi hotspot, Zeppelin hotspot. Is this one? Yeah. So in this case, for example, we have it was not an ESP32, it was a ESP8266, so it has even lower memory. And we have the motor directions, the IP. In this case, we will publish in the ESP as a self network. So in this case, we are not calling external files, and we want to send the HTML requests. What is the HTML? Actually, the HTML is not inside this Arduino code. It was hosted externally. And it's funny that it's not called, sorry, HTML. It's an index.h. When you compile as an external, you don't actually put that is a HTML because the Arduino doesn't compile with it. You need to call and state that the file that you are calling is a index.h, but that index.h is actually an HTML file. So it will compile as a HTML. So you can see here, we can have some, we are calling some JavaScripts, your Ajax JavaScripts, and some libraries to actually have the responsiveness of the buttons. And we have also the CSS file hosted inside the HTML. So we try to reduce as much as possible. And the classes are really, really small, as you can see. And we have the head with the image. And as you can see, where I'm loading my image. Actually,
you're using another space to put it there. You can use it, I don't know, a YouTube image somewhere.
Exactly. You can call whatever image that is online. But if you want that it doesn't lose forever, actually Imur is a way of linking files in a short address. It's not a server by its own. So actually the image, if you go onto the GitHub, sorry, I'm trying to open my GitHub, then GitHub, FabLimp. The image actually is in here. It's in the repo of the GitHub. So actually we are using this repo not only to publish the workshop content and that everybody can fabricate, and the instruction plans is quite similar to the Arduino actually. We just also have some basic codes and some pieces of code that are inside here. To do what? To actually take the images. For example, I think the image is here, image, yeah, image. We are calling this GIF from here, from this GitHub repo. So we always know where it is. So actually, if you just view the image and we actually do this, copy and put here, what we will do is calling this big GIF image from the server. at the GitHub server. And the good point is you can do this with everything. Libraries of text, libraries of responsiveness of JavaScript of Bootstrap, and you can do with this with videos. So you can actually enable a full background video audio of HTML that looks super cool, but actually just the text of calling to it is inside the USP, not the main video on its own. So you don't have the file size constraint. That's why you always want to have the ESP not a hotspot itself, but as a server, station mode server. So it's connected through a local network that is connected through the internet, so we can call up to things. And this is just the responsiveness on actually how to call for actions. In this case, we were using Ajax. And Ajax call response is basically, Xavi can actually explain this much better, but is when you use Ajax, what you do is update, send an HTTP request, the ESP is sending you a HTTP response, but it's doing this much faster. So actually what we are doing is refreshing the web page all the time. We don't have just a page that you call it and it gets static. It's refreshing, self-refreshing all the time. And by so, it makes it less stable and more prone to fail or to have other problems. So actually, what Xavi is going to explain you is actually how to not use Ajax and use, for example, WebSockets to kind of do the same. And basically, for example, this is really nice because actually it's how to use Bootstrap to make a full web page. Let me see, where is this? We have also used this. Let's go Bootstrap. No, I want to see the example one. Oh, if not, I think I have it already here also. I can just compile it with you. Winemakers, yes, resources. Winemakers, presentaciones, datos. Where's the Winemakers one? PCB codes, yeah. So actually, yes, for example, I'm just gonna do in live. So basically with this inno, we are calling an index file, and you see this data. This, when you use SPIF memory, the files that you put in your SP memory needs to be inside a folder that is called data. So Arduino knows exactly which files need to be saved in the SPIF memory and which ones not. In this case, the data is empty. So because we don't have it, but by default, it's a good instructor to always have the folder structure in this way. And as always, because live demos is what they are, I'm pretty sure it's not going to work because I haven't tried this code in a lot of time. In a long time.
And if you want to like save data on the server, is it better to kind of like like online? I mean, is it better to save it locally and then upload it online so we don't like miss data points in case of connection or something?
Sorry?
If you want to like save some data on a web server rather than locally, is it better to still save it locally and then upload it to make sure you can record everything? Or
yes, you can do that, and you usually, well, at least I have done with Firebase, that basically you are writing to a JSON file or a CSV file and you're calling back from it. For example, this, I need to set up the Wi-Fi connection and upload it so I can see. So I'm gonna stop sharing my screen so I actually input my Wi-Fi connection because I don't want that this gets everywhere. And actually for the Wi-Fi password. So let me 1 second. I need to go and take a picture to the router.
In fact, Marco, this is Xavi. What you can do is do it both. I mean, save it locally and also save it in a web server or something like this, just for security. I think that Oscar they do like this in Smart Citizen, no? In the SD card and then in the server.
Yeah. If the main purpose of the device is to collect data, of course, have an SD. Okay.
You're still sharing your screen.
Yeah, I know. Thank you.
Good call.
Still sharing it.
No, I'm not. What is Zoom? Sorry, I can share. Come on. Whoop. ESP Wi-Fi. I don't have the library installed actually. Let me see if I install the library. I will try to do it fast. If not, we can jump onto Xavi's session. I don't want to stay like all the day here. Yalla. Okay, let's see. No, actually I don't have the library. So I'm sorry I cannot make the live demo. But basically you can get it. For example, this HTML right now I cannot see in a browser. So a good way so I can see in a browser and I can compile in a way that I can see, I can call as a HTML, rename it. And basically this is what my personal workflow is. I always work as a HTML and after I just change the extension file name. So actually the HTML, it would look like this. For example, I call in a lot of scripts to make everything responsive and update. So actually I'm code Cloudflare, etc., Bootstrap. Actually, this is more the standard links, more or the most of the Bootstrap ones. And I have data tables, some panels, and what we are doing here is publishing some graphs all the time. So actually this page, what it does, if it was properly connected to the ESP, it will be publishing actually data graphs from the sensors. In this case, it was for a voltage sensor, so it was measuring the inner voltage of the ESP, the temperature sensor, because we have a DHT humidity and temperature sensor, and humidity, and the density, because we have also some laser rangefinders to actually control the density of the wine. So it was publishing the data in live, and we can have it as a actually this was calling another page that it doesn't exist, so that's why it doesn't work, and we have all the graphs. So in short term, this is how actually you can embed HTML pages inside ESP. Do you have any questions in general? No? Okay. I think
maybe one, which is just, is the advantage of hosting the actual web page on the ESP just so that it's faster when you access it rather than if you hosted it online and then it has to get it from online?
Okay, what you could do actually, for example, good question, Benjamin. For example, you can have access a web page in a GitLab repo, and you can activate the button, and that button write, for example, to a JSON file, and make the ESP read from the JSON file. But for that, you need to have APIs of control and APIs code, so you can access safely to those files and write remotely from them. You remember, for example, when you want to write to your repo, you need to put your SSH code, etc. So actually, yes, you are able to do it if you want to do super complex pages that are huge and immense. At some point, it's better to do it in that way. But if the web page, and most of the web pages can be compressed really lightweight, it's much easier to have everything locally inside the ESP, because it simplifies in the way that we don't need to set up any API of connection, and that means we need to make pull requests to the server, and that many times could lead to a delay, as you state. But that actually doesn't happen. And Xavi will show you actually live control through WebSockets and requests without any kind of delay, like real-time control.
I have a question. The case of having a lot of this ESP collecting data around the globe, and a unified database, like it's sort of like a distributed way of collecting data and visualizing it onto one web page. This kind of makes the case of doing the host on GitHub, writing the JSON file and calling through APIs. Like when you scale it up, it makes more sense.
Actually, that's the model of how the smart citizen works, Oscar. So actually, I think you can make us a small tip.
Sorry, I was not listening.
No. For example, we're having the question of, for example, let's say you have 200 ESPs connected to the wall, collecting data. It doesn't make sense to actually have one page in each one of them and publishing the data. So actually what they are doing is writing to for example, a CSV file or JSON file and making API requests to write to those data. Actually, that's more or less how you're doing in the Smart Citizen. No?
Sorry, I really don't understand.
How the Smart Citizen works, because actually the Smart Citizen is connected through Wi-Fi.
Yeah.
To actually send the data to the Smart Citizen page and publishing the data in live.
Yeah. So there's a server in the back that has like a database that stores the time series. So the idea is that there's a protocol called the MQTT and an MQTT broker that is listening to all the smart cities in the world, and is basically saying, okay, devices from this device with this ID is sending me this data. So that is that data that is sent by the protocol MQTT then goes directed to the database, and that database has an API that basically is pulling data from the database and exposing some endpoints so that you can request that data. And basically the front end, which is the website page that you see, is making requests to that server via the API, the same way as you would do. So the thing is that no one is talking directly to the website. There's a server in the backend that stores the stuff, and the devices don't talk to the server. They talk to an MQTT broker, and the MQTT broker sends the data to the server. But I think this is a little bit more like a topic for next week, and I think not next week, but for the networking week. And I am trying to arrange with Guillem and Victor and the other Victor, the Victor from Iceland, a small session, like 1 hour or two, about platforms and servers and CDNs and this type of things, so that we can explain a little bit better this type of architectures. Because this is like, if you have networking already, and we haven't done that yet, then we will be able to talk about these things. But otherwise, if I talk about MQTT or Edu talks about HTTP requests, or whatever, it sounds a little bit like Chinese because we haven't talked about networking yet. So we will talk about that, and then we will talk about platforms. And yeah, that's it.
Thank you.
So with that, I think we can jump on to Xavi.